In this equilibrium problem, we have a 500 Newton child and a 350 Newton child that sit on either end of a 3-meter long seesaw. How far from the 500 Newton child should the fulcrum be placed to ensure rotational equilibrium? So we draw a free body diagram. We have two children. This one is 500 newtons. And we don't know the distance. And we'll save the angle for later. This child here is 350 newtons. So I'll label this as F2, 350 newtons. We don't know that distance either, and we'll save the angle for later. Since this child is larger, the fulcrum should be placed closer to that child. Now I'm going to label this distance because I don't know it, I'll label it as X. It is an unknown. And the total length of the seesaw is 3 meters. Now, I don't want to label this other distance as a second variable like y. And the reason is because then I have two unknowns, and when I go to solve, you can't solve an equation in which you have two unknowns. So we're going to be clever about this. If I knew that x was 1 meter, I would automatically know that the other distance is 2. Well, how did I know that? I would have subtracted 3 from the distance of the first child. So I'm going to label this as 3 minus the distance of the first child, which is our unknown x. And in this way, I still only have that one variable, x. So I'm not introducing a second variable, and I'll be able to solve later. Now to get the angle, I'm going to draw a straight line from the axis of rotation to where the force is, and draw in the direction of the force. So we see that that angle is 90 degrees for the first child. And I'll do the same thing for the second child. From the fulcrum to where the force is, and then the direction of the force. And that angle is also 90 degrees. Now we are in rotational equilibrium, so my equation is going to be the same as before. Total torque is 0, where the torque is Fd sine of theta. As long as the force is not at the fulcrum, which is right here, there will be a torque produced. So I have two forces that are not at the fulcrum, and so therefore there are two torques. I'll label them as torque 1 and torque 2. Then we have to determine positive or negative. Torque 1 is going to make the seesaw rotate clockwise, so that's positive. Torque 2 will make the seesaw rotate torque 1 will make it rotate counterclockwise, so that is positive. And torque 2 will make it rotate clockwise, so that's negative. So torque 1 is positive because it'll go counterclockwise. And torque 2 is negative because it'll make it go clockwise. I'll replace each of these torques with the force times the distance times the sine of the angle. So force 1 is 500 newtons. The distance is unknown. And the angle is 90 degrees. Torque 2, it's minus because it's plus and negative. Force 2 is 350 newtons. My distance is 3 minus x, and my angle is 90 degrees. At this point, I can simplify. Sine of 90 is 1, so 500 times x times 1 is 500 times x. 350 times 3, we have to now distribute, times 1, again sine of 90 is 1, is minus 1050, and then negative 350 times negative x is positive 350x. I can combine the 350x and the 500x because they both have the same variable attached. So I get 850 times x minus 1050 is 0. And I can solve for x at this point. Move the 1050 to the other side, divide by 850, and we get 1.24 meters is our distance. And that is the distance of x, which is our distance from the 500 Newton child, which is what